Alright, so now we're moving on to 1.7, transformations in the plane, the coordinate plane. Again, this is an introduction to another chapter later on. But as per usual, there is an awful amount of new vocabulary. Check it out, as I say, make notes of anything you do, and as you go along you will see that the definitions are explained as we go further along. So a transformation is a movement, a function that maps a figure from its original figure, which is called a pre-image, onto another image. Okay. Now, if you look at the diagram that we've got here, they're moving the original figure, which is the pre-image ABCD, and they're translating it into an image. Now, in the diagram here, they've used different letters, so X, Y, and Z as against ABC. If you are using the ABC, which you can, you need to put little dashes. So, for instance, if A is going to A dash, okay, so you put a little dash. So instead of X, you might put A dash, okay? So you'll see that sometimes, and especially a bit later on in the book, all right? So there are three different types of transformations in the plane. The first one is a reflection over a line of reflection, which is this guy here. The second one is a translation, and that will be in what's known as in vector form, okay? Now, vectors, there is a definition over the next page, but vectors are very similar to coordinates, but this time they've got more like square-based parentheses, okay? So you'll either see the word vectors or you'll see it like that, and that will tell you that you move the X coordinates 4 places, and then you move up 1 on the Y coordinate, okay? So it'll either have the word vector or it will have these sort of notation as far as your parentheses are concerned, okay? And then finally is your rotation. Think of a steering wheel on a car, a wheel on a car, or a bicycle, etc., etc. Okay, so each image is reflected over a point of rotation, okay? And as you can see from the diagram here, the distance from the point to T is the same as the distance from the point to Y. And for that you'll need a calculator, not a calculator, a protractor. Alright, so how do you identify the different transformations? Well, you've got to work out whether it's going to be a rotation, a reflection, or whether it's going to be a translation, okay? So look for things, but make sure you've got to, like for instance in A, the only way you can get from the image, pre-image to its image is by rotating it, so that's definitely a rotation, okay? The B1 is, it looks like a transformation until you realise that it's been, it's reflected in itself, so that's definitely a reflection. So don't forget you've got to be looking for the point of the line of reflection as well. And then finally C is a translation, so it's 3 up to the left, 3 units to the left, and 3 units up. So if I was putting that in vector form, I would do -3 because it's going to the left, and it goes 3 units up, so that's going to be +3, okay? So either it'll be a translation and they'll say it's either just 3 units to the left and 3 up, or they'll put it in vector form. And as you can see with the questions, rather than doing questions 1, 2, 3 and 4, I've skipped over a little bit, but it's still example 1. And the reason why I've picked these in particular, so let's have a look at question number 5, all right? So what is happening with number 5, and it doesn't matter, all you've got to say is which one's a reflection, rotation, or a translation, and it doesn't matter if it's not labelled like none of these are, which is which. So for instance, let's just take the blue as the pre-image, so I'm moving it over to the green, and then which way can you do it? Well, it can actually be sometimes like this one, it's actually all 3, okay? It's a reflection, so for instance if I put my line here, in other words the y = x line, it's being reflected over that, so first and foremost it's a reflection, okay? What else can it be? Well, it can be a translation, and if it was a translation, then what's happening to the point. So you take a point, what's happening to that point as against this point. Well, it goes to the right 4 and it goes up 4. So that'll have a translation of a vector 4, 4. You don't have to put this, I'm doing it for your benefit. And then obviously the other point it can be is if the origin was the point, we could also rotate it. Okay, rotation, I'll just put rotate. And that's about the point 0, 0 or the origin, whichever you decide to put. Okay, so that's question number 5, that's all 3. So be careful. Alright, so let's have a look at this real life situation. What you've actually got, which is what it says, refer to the information on the left, is actually a person's leg with one of these balls that go around the ankle. So unfortunately I missed that off. But anyway, if you're looking at it, it says what's going to happen to it. Well, if you could imagine that this is the person's leg, and these are the weights that's moving around. It doesn't matter which in direction it's moving, whether it's going that way or whether it's going that way. But as you can see, it's a rotation about the person's ankle. So let's have a look at example 2, which is question 8 in this respect. Okay, and again, look at what's happening to the chess pieces. It's actually a pawn, but apart from when it's taken, it doesn't move diagonally, but in this one it does, but it doesn't really matter. Okay, but if you can imagine that this is the pre-image and it's going to the image, which is over here, it's obviously gone across and up. Okay, so that's a translation. Okay, so I put all these in on one page rather than move it along, but let's have a look at what happens to the coordinates when you are reflecting or translating or rotating either counterclockwise or 180. Okay, in a reflection, let's have a look at what happens to, this is in the x-axis. Okay, so if you could imagine, if you've got your coordinate here, if you've got something here, if I'm reflecting it in the x-axis, well, in this coordinate, it's positive and positive, okay? If you think of the x and the y. Well, if I reflect it over the x-axis, then the x is still positive, but this time the y coordinate will be negative, and that's what you see here, okay? So you take your x and y coordinate, your x stays positive, but your y will go negative. If you reflect it in the x-axis, this time the x goes negative and the y stays positive. Okay. All right. Translation, and again, what we've got here is a vector of a and b. So what happens? Well, obviously in the notation they're both positive, so you're going to add whatever it is that they give you for the coordinate for a onto the x coordinate, and whatever distance they give you for b, you will add to the y coordinate. Okay, and then again, coordinates, what happened to coordinates if you are going counterclockwise? So again, if you've got something here and you're rotating it counterclockwise, that's going in this direction, so we've got something that will now be over here. Well, let's have a look at what's happening. Your x and your y numbers that you've got, you revert them, and then obviously you change the y-axis or the y coordinate to negative. The positive stays as the x, but as you can see, they go in different order. Okay, and then the same with 180 and the same with 270. Okay, so you have to remember these. Unfortunately, it does help you though when you are then redrawing the image from the pre-image. Alright, so the first thing they'll give you in a question in example 3, they're going to give you the coordinate of the shape. In this case, it's going to be a triangle. Now, before you draw the diagrams, best thing to do is to put them in some sort of order in which you can see. Okay, now let's have a look at what we're doing. We're reflecting over the x-axis, and we know that your x and y, if you're reflecting over the x-axis, the x still stays positive, but the y becomes negative. Okay, that's, remember from what we've just done. So plot your coordinates. Before you plot your coordinates, put them in some sort of column order like they've done here. So your 3, 2 will become 3, negative 2. Your 2, negative 2 will become 2, 2. Okay, and again, the other thing you need to note, as you notice that they've used the same letters, but they've used those dashes that I talk about. Okay, I've talked about earlier. And then once you've done the coordinates, then you can plot your diagrams, and it is better if you use different coloured pens on your iPad. All right, and then before we do any questions, we go straight on to example 4. This time you've got a quadrilateral, Q, R, S and T. Again, they've got the 4 coordinates. And then this time you're moving it in a vector of 7, 1. So all you've got to do is take your first coordinate. So Q will go to Q dash. So Q at negative 2, negative 8, negative 2. If you add 7 to negative 8, you're going to get negative 1. And if you add 1 to negative 2, you're going to get negative 1. So do that for all the other 3 corners. Once you've got this part sorted out, then plot them. And then finally, example 5. What have we got in example 5? Again, we've got a quadrilateral, but this time we're going to do a rotation over 180 degrees about the origin. Okay, so what you've got to do is you've got to take every vertices, draw the line through the origin, and it's got to be equal distances. Okay, so put construction lines in first. So for instance, do a line like that, and then measure this distance here, and you should be able to see it on your paper, but if you can't, use a ruler. And then once you've found the distances, so from F to 0, as you can see, it's 2 to the right and 1 up. Do the same with the F dash, 2 to the right, 1 up. And then again, do the same thing with all the other corners. Make sure that you are going through the origin every time. Okay, and then work out distances. It looks like a spider web, but it does help you when you have got to draw your lines accurately. All right, so let's have a look at question number 3. Using that, for question number 3, you've got to do a reflection, you've got to do a translation, and you've got to do a counterclockwise. So let's just have a look at what would happen to the coordinates in question number 3. I'm just going to do the x coordinate at the moment. So for 3 part A, okay, this time we've got your xy, but we do know that when you reflect it over the x-axis, the x stays the same, but the y becomes negative. Okay, so your negative 9, 4 will go to negative 9, negative 4, and then obviously you'd need to plot it. All right. A translation, don't forget, is just whatever the vector is. So in this case, if we look at now the 3b part of it, okay, we've still got our negative 9 and 4. But this time we've got to add 4 and 6 to the respective one. So negative 9 add 4 will give you negative 5. Okay, and then your 4 add 6 will give you 10. So now you've got your new coordinates, and then eventually you can plot the diagram. Okay, and then what we got, a rotation. Don't forget rotations. And I've lost it. Sorry, rotation 270. What happens this time? So 3C is going to go your x and y. XY, that's going to go to, they swap round, remember, y, negative x. So let's have a look at what you've got now. So we're doing your negative 9 and 4 still. Okay, so negative 9, 4, that's still staying the same. What happens is you revert them. So it's going to go 4 there, and your y is going to be negative. Well, it's already negative, so it's going to be a positive 9. Okay, so once you've done that for all of them and all 3 of your points, so once you've got your points, now you can plot them all.